It's the opposite. What do you think infinite means? Infinite means it goes on forever and ever and ever. So, for example, 2, 4, 6, 8, dot, dot, dot. It goes on forever without end, right? If it's finite, it actually ends. So my sequence would be like 2, 4, 6, 8, end. So this sequence only has 4 terms. Can I add up those 4 terms? Yes, I can. This sequence goes on forever to infinity. Can I add up this sequence? No, I can't, because we've said that it diverges to infinity, so I can't add it all up. So this says, what is an arithmetic series? An arithmetic series is just the sum of the terms in an arithmetic sequence. So it has all the same attributes as an arithmetic sequence, but instead of commas, you're just changing it to plus. So if the sequence was 1, 4, 7, 10, your series is 1 plus 4 plus 7 plus 10. So there's a big notation difference. So S sub 6 tells you that you're looking at a series. So on all of the homeworks up to this point, it was A sub 8 or A sub 20. That means the 7th term or the 20th term. If you say S sub 6, you're not saying A sub 6. A sub 6 would be the number 16. S sub 6 is adding all these terms up, and the answer is 51. So it's an important notation difference. So obviously, we're not doing a quiz this week on series, but on your test on series, if it says A sub 6, you would be finding the number 16, and if it says S sub 6, you're finding the sum. Think about S for sum. And then here is another way of saying it is finding the partial sum. So that's another vocabulary word that you'll see. That just means S sub 10. So you might see them say, add up the first 10 terms. You might see S sub 10, or you might see the 10th partial sum. Why is it partial? Because it doesn't go on forever. So it's the 10 terms you're adding up together. Here's that example about listing the terms in pairs, which I already did a few, but if you wanted to do 2, 5, 8, 11, 14, all the way up to 29, what you do is you take the lowest and the highest, and what do you notice that all of those pairs of numbers add up to? They all add up to the number 31, and there were 5 pairs of numbers. So the answer was 155. So instead of plugging it into our calculator, 2 plus 5 plus 8 plus 11 plus 14, you could just do how many pairs are there, and then what's the sum of the pairs. I think it makes it a lot easier. Yep. Okay. Go for it wherever you need to go. There are 20 numbers. You're counting by odd integers, 1, 3, 5, 7, all the way up to 39. So if there's 20 of them, how many pairs would there be? If you have 20 shoes in your closet, how many pairs of shoes do you have? So you have 10 pairs, and what does each pair add up to? Right? You have the first term, and you have the last term. You have 40 times 10 pairs. So sum would be 400. I could do that without a calculator. So this would be on like the non-calculator section, because I don't want you to actually type in 1 plus 3 plus 5 plus 7 plus all the way up. Okay, number 3 is hard only because it's hard to figure out how many numbers you have. I don't want to count from 205 up to 300 and figure out how many numbers that is. So how many numbers are there from 15 to 20? 15, 16, 17, 18, 19, and 20. How are there 6 numbers from 15 to 20? It's starting from 0 and going to 5. You're going to have 5 numbers. Right. But doesn't your brain want to say that there's 5? To me, when I look at this, I say, oh, there's 5 numbers. But there's really an extra number because you have the beginning and the end. Right. Or you don't subtract both of the ends, basically. So I want you to think about the shortcut is, if you're going to subtract the distance between them, you need to add 1 back on to count all of the actual terms. So in number 3, how many numbers are there if you're doing positive integers from 205 to 300? 96. And I feel like the common response is 95. But it's 96, not 95. I was kind of proving it using a smaller set of numbers. If I'm counting from 15 to 20 and I list each of my terms, how many do I have? I actually have 6. Because when you take 20 minus 15, you're not counting 20 as like one of the terms. You're counting the distance between 15 and 20. And it would have been okay. We could have still done the problem even if I had 95. Because you can have half of a pair. But I actually have 96 numbers. So try number 3. You should be able to do number 3 pretty easily now. Number 4 is a little bit challenging. You want to find the 150th partial sum out of 150. You need to figure out what a sub 150 is so that you can add up the first plus the last. And we should be able to figure this out using the arithmetic formula. So I'd like you to try to finish 3 and 4. This is as kind of hard as it gets with arithmetic series. This is the problem solving that you'll have to be able to do. Using the pairs formula, solving for a missing term. I should have written, so there's 96 terms, because if you use the example from 15 to 20, 15, 16, 17, 18, 19, and 20, there's 6 numbers. When you subtract, you would only get 5 because you're not including both endpoints. So you need to subtract the 2 numbers and add 1. So when I subtract the 2 numbers, I get 95 and I add 1 to 96. And then on this problem, you need to do the first 150 numbers. You need to find term 150 so that you can use the formula. Times what? There are 96 numbers. But this is still the first term and this is still the last term. So for your sum is 505. But we need to figure out how many pairs there would be. We're using 505, and then what's the number of pairs? There's 96 numbers. So I have 48 pairs. So you're doing 505 times 48. Because 205 is the first part of the sequence. You're doing positive integers, right? So the first positive integer is 205. The last positive integer is 300. So 505 is the sum, and then 48 is the number of pairs. 508, what is that? 505 times 505 times 48 is 24240. 24240. So that kind of problem, you would have to have a calculator on, but you'd have to explain, well, the sum of the first plus the last term is 505, and there are 96 numbers, so there would be 48 pairs. Number 2, you should be able to do without a calculator. 40 times 10 is 400. So I'd probably give you more of a problem like this without a calculator than this without a calculator. Okay, so number 4, I know the first term is 5. I need to figure out what the 150th term is using the closed formula, right? 5 plus whatever this is, 11 times n minus 1. Plug in 150 because you need what the last term is of this sequence, right? What is term 150? Then you'll be able to find the sum of the first plus the last. If there's 150 terms, how many pairs will there be? No, would it be 147? They're telling you there's 150 terms. The time that you subtracted and added 1 is when they didn't tell you how many terms there were. There's 150 terms. How many pairs are there? 75 here, yep. And then I don't know whatever the sum is. Did you do the sum? Base of n is 5 plus 11 times n minus 1. I need to put 150 in for n. And that's my last term. I think it's a bigger number than that. 5 plus 11. Yep, 1644 is the last term in this sequence. So you're going to add 5 plus 1644 and then multiply by 75 pair. 16, yep, 49 times 75. Well, because you're taking 1644 and adding 5 to get the sum. You always add the first plus the last. That's what that pattern was I put over on the board. So 1649 times 75. 1, 2, 3, 6, 7, 5. Did we get there? So I always think about that 1 to 100 problem when I'm setting these up in my head. So I think about what's the sum, and then it's the sum times the number of pairs. So this example was 101 times 50 pairs. So it's a big idea. We're going to practice it today and tomorrow, but that's the third formula that you need memorized. The two closed formulas for arithmetic and geometric. And really, if you just have the concept, then it's the sum of the first plus the last times the pairs. That's a formula. So you need to know that formula. And there's one last formula for geometric sigma notation we used. So I don't have a lot of room to write it. I'm doing the sum. I'm going to use x. X goes from 1 to 100 of 1 plus 1 times x minus 1. That's what we just typed into our calculator, right? And then we said the sum was 50-50. We know the sum was 50-50. How did we write the other one? We did the sum from term 1 to term 20. And what was this one? 1 plus 2 times x minus 1. To me, if you know the pair formula, this is more work to type in than just thinking up the first plus the last. This came out to 400. So let's do one of these applications together. We're going to do it using the pair formula, and we're going to use it with sigma notation. So this isn't a golf tournament. The 16 golfers that have the lowest scores win cash prizes. Maybe there's like, whatever, 60 people competing, and the lowest 16 scores win a prize. First place gets $1,000, second place $950, third place $900, and so on. So we want to figure out how much prize money are we giving away. So the first thing we're going to do is use the formula for our finite series. How many pairs would there be of numbers? There's 16 prizes total. So there would be 8 pairs of prize numbers. I don't want to list all of them, but 1,000, 950, 900. I need to figure out what the 16th prize is. This is the first place. This is the 16th place. So I can add them together. That's my sum, and then find the number of pairs. How many pairs will there be? There's 16 places getting awards. So there's 8 pairs. How can I find out the last place amount of prize money? You could, then you'd have to list them all. We're going to have to come up with a formula anyway for this second part. What's the formula for this? Base of n is 1,000 minus 50 times n minus 1. So you plug in the 16th place and figure out what the 16th place prize is. So do that. What do you get for 16th place? Take 1,000 and subtract 50 15 times. What's last place get? Well, you're plugging in the number 16, and 16 minus 1 is 15. So 1,000 minus 250. Last place gets 250. Last place, but they're really 16th place out of whatever, 50 golfers or something. All right, so how do I add it up using that formula? There are 8 pairs of numbers, and how much does each pair of numbers add up to? What's my first plus my last? Right, so I would do 1250 times 8 will give me my answer. How much prize money do I need to go get at the bank? Probably they would use their entry fees, you know, and they're going to give away $10,000 in prize money, but they're going to keep $10,000 to run the tournament or whatever. So they need $1,000. I want you to see if you can use the summation key on your calculator. Think about what you'd have to plug in to get it to say it's $10,000. We know 10,000 is the correct answer. Sometimes it's nice to be able to use the summation key if you don't know the last term of your sequence. Uh-huh. Did you figure out how to type it in? You're going to want to go from 1 to 16, right? From first to 16th place. And then you're just going to use the formula that we already wrote down. Is everyone getting that correctly on their calculator? It's really important. If you don't know how to type it in, now's the time, because sometimes you have to use your calculator. You can't just use the summation formula. How many terms were there? There were 16 terms in your sequence. First place through 16th place. So this is kind of like it's called your lower and upper bounds of your summation. Term 1 to term 16 or term 1 to term 100. Did you get it to type in? Show me that you know how to type it in. Here you go. Show me that you know how to type it in. I want to see the summation and the 10,000. Summation and 10,000. Happy. I want to see it. Show it to me on your calculator so I know you all typed it in, because the day's a test. I don't want you to like, oh, I never learned it. I didn't know if you do pass the answer key to her. That's on your desk. Four. Do you have it, or did you put it back upstairs? Did I say you didn't check homework off today. No, but I did when you were out of the room after lunch. Did anyone else do 5-3? Elise, did you? Yesterday it was supposed to be due, so today I said I'd expect it, not late. You all were like, oh yeah, I'll do it. This is 5-3. Yours is not late. You didn't know until late. But it was not assigned last night. No, I know, but they would flex today. You didn't come to my flex. I didn't know. Whatever. Corey said, okay, sorry, but you could have done it in flex. Okay. So you are now going to try example 8 on your own. Oh wait, what time are you? Oh, 57. So you should have time to try example 8 on your own, and then the guided practice. We'll just start with the guided practice at 10. So try example 8. I was going to check off the first set. This one I haven't really yet. I wasn't here for that. That's all arithmetic. I don't know. I just put it in all there. One of those two has to get put in. We have to use applications before the test. This was the sequence. This is all sequences. Part 1 and part 2 of practicing sequences. So I would say as long as whatever day we end up doing less, just get it done. 1 out of the 2. Yeah. Did you already show them to me? You're doing number 8 as your last bit of business for the day. Number 8.